So what we should do, infinite test, you check the work on page, because we are going to look at tests for convergence. And the first one we are going to look at infinite series test. And this is in our handout, you check, that is the work on the top of page 42. When you check properly, that is the work on top of page 42. That is the work we are talking about. And we are going, in this case, we are going to have some review about them. One is that this is how we obtain the convergence. The procedure, we have one. We obtain sum n, i.e. the partial sum. Two, partial sum, I think, remember, we take a certain value of limit. Then we take limit. This is what we tried last time. We take a limit, and if this is if the limit as n goes to infinity of this is the partial sum goes to L, then we say that the cell converges. It's what we looked at last time. Otherwise, it diverges. So that is what we are saying. In this case, we can have some specific examples. So the procedure should be at our fingertip. I think you should know that you obtain the partial sum of the cell. That one we know how to obtain it. We take the limit. If there is a convergence of that partial sum, then we conclude that indeed this one here converges. But if it doesn't exist, then we already will reject, like the way we did last time. So again, our examples show that this is the cell, which is 1/2 power n converges. We can say converges to 1 because the answer, I know it is 1. You know it already. So the solution is clear. This is the sum of 1/2 power n be equal to, when you substitute in n is equal to 1, we shall get a half. Then we add, when we put in 2, we shall get a quarter. When we put in 3, we shall get 1/8 plus others, because this is a sum to whatever, to infinity. It will continue up to infinity because we are dealing with a cell. So the partial sum here, please, I have said this is the work on top of page 43. Sorry, top of page 40, is it 42? But the work which is there is not so much organized. So what I'm saying, I'm deviating a little bit from that work. Then follow the one I'm doing now. I'm going to tell you the pages when I go back to the handout. I'm going to be telling you the page where we are every time. So our partial sum can be, this is a half plus a quarter plus 1/8 plus up to 1/n. And in this case, or just, we can just say plus n. And in this case, we are saying that our R will have a common ratio which is the same as 1 over 4 divided by 1 over 2, which is 1 over, and tell us what is this? Zeta half. Also, still, R is the same as 1 over 8 divided by 1 over 4. I think we shall get still a half. So you see that we are having a common relation. Therefore, we are supposed now to identify the expression we are having, that now we are having sum to infinity. So taking the sum of the first n terms of a GP, because we have seen we are having a common ratio, therefore our partial sum Sn will equal to what? This is A into 1 minus R to N over 1 minus R. Why am I taking this? Because our R is less than 1. Remember, we said if you have a situation where R is greater than 1, we know what to do, that we interchange this part here. We take R minus R power N minus 1. Then we try to see what next. I think you remember I talked about it last time, so I'm sure you know. So this is the equivalent to this is a half into 1 minus. This is a half into 1 minus. Our R is a half to power N over 1 minus. This is a half. Can you see that the whole of this will go with this? Because this we shall remain with a half, and this is already a half. And then here we shall have something close to, this is 1 minus 1 over 2 to power n. This is what I'm remaining with. And my next interest is to take a limit. I've said you take a limit. Therefore, taking a limit, we have this is the limit as n goes to infinity of this is Sn. This is the equivalent to limit as n goes to infinity of this is 1 minus 1 over 2 to power n. And this is the equivalent to 1. So when you try to check, this is a 1 already. And therefore, we conclude in this case that our infinite series converges. So we say that we conclude that this is the series 1 over 2 to power n converges. And to be specific, the series from this is n is equal to 1 up to infinity of this is 1 over 2 to power n automatically equals to 1, because we have seen that it converges to 1. And I hope now you know that these ones here writing this and this, they are the same. So why? Because we said here we are taking an infinite thing, therefore it moves from n is equal to 1 up to infinity. So it's a matter of just writing like that. Hope you can remember that expression. So number 2, we can say show that we can have this is n squared diverges, that series diverges. So when we have this, we know that this is a series. So this is n squared, this equals to n squared, which is 1 squared, which is 1 squared, 2 squared, 3 squared, plus others up to infinity. And if that is the case, we are taking a partial sum of this. So our Sn equals to what? This is 1 squared plus 2 squared plus 3 squared plus up to, this is n squared. This is already the standard definition we know. And this is equivalent to n over 6 into n plus 1 into 2n plus 1 from the other definitions. So taking limits, we have what? What do we have when we take the limits? You will see that we are going to have this is the limit as n goes to infinity of this is Sn equals to the limit as n goes to infinity of the whole of the other expression n over 6 into n plus 1 into 2n plus 1. And this one here will go up to infinity because there is no way we can carry out n when we take a limit. So it will keep increasing whenever we increase n. It will not converge to a certain value. And therefore, in this point, we can say it converges to infinity. So this guy here, n squared, diverges to infinity. And remember, we said when we say diverges, in most cases, if it is a set, we say it diverges up to infinity. So that is the expression, or that is one of the whatever there. So you will see that the other expression given in your work, which is 1 over this is k into k plus 1. This one here, you have to go to partial fractions, then so that you can obtain that expression. They are having 1 over k into k plus 1, which is 1 over k minus 1 over k plus 1. So that is where they are picking it from. Those are partial fractions, high school work. So I'm sure you can manage to go and get that answer there. So the next one, we say the next test of convergence, the second one. Yes.
On the first example, the partial sum. The last time you gave us plus n, isn't it? 1 over 2n.
Plus n?
2 to the power n.
You're saying I gave you what? Where?
The partial sum, the series.
Yes, the partial sum. This is the partial sum here.
Yeah, you said plus n, isn't it? Plus 1 over 2 to the power n.
You are free to take that, which is, you are free to take 1 over 2 to the power n. It is okay.
Okay.
Thank you. So, let's move on to the next. The second one, we have said we are going to look at today. It is the geometric test. Geometric test. Can you please go there? Geometric test. You go to page. You go to the bottom of page what? Bottom of page 43. That's where it is. And you read it through. I'm just giving you half a minute. It is the bottom of page 43. Check. That is the geometric test. So you will see that from that work given there, we are already using R. We should learn how to use R. Then we know A. A is the first term. Then we know R is the common relation because we are dealing with a GP. Automatically, you remember the other formula we are using of a GP, they automatically come and arrive here. So we are supposed to use them. And in this case, what you should specifically remember is that we are picking A from R, and also we are picking R from R. I think you remember this. And therefore, if you are having a term, you are having R, magnitude of R less than 1, then automatically we say that the set which is of this kind here, this converges. Otherwise, meaning that if our R is greater than or equal to 1, then it diverges. It is the only thing we use here to test. As I've said, go to the bottom of page 43. It's the only thing we use here to test. And when you try to check, K starts from 1, meaning that the first formula, we have this is sum equals to AR K minus 1. And when you expand this, it implies that the first one, you start with the K. Now instead of N, which is coming from N, we are using a K, which is also coming from N. So don't get confused over that. I think if you are not contented with this K, you can just use A R N minus 1. And when you substitute, you know this will be A because this will be R to power 0. Then this is AR, the next one when N is 2. This is AR squared. And automatically it will continue because this is a set. Specifically, now look here, please. Look here. If I change this component for some, and I think about the other way around, another way of writing it, I will say, remember, if I write like this, then it implies to me that N is equal to 1. We say the 1 to this is infinity, and this is AR N minus 1. This thing is the same as this. Now, you should be specific, or you should be a bit conscious when you are reading this, because sometimes they, instead of writing that, they just write for you like this, and they say our R now, or our N is now running from 0 to infinity. And then they tell you that this is the same as A, R to N. Now you will see that here we are starting from 0, and here we are starting from 1. So the formula changes a little bit. It is adjusted a little bit when you try to check at that point. And specifically, it implies to me or to you that here you pick, here this N you see here, this N you see here is not a member of N. Why? Because it includes a 0. So here you should be specific, and therefore you should know that I'm not dealing here with N, but they have added a 0, and therefore my N here will be 0, then a 1, then 2, 3, and others. But here my N comes from N, and therefore my N starts from 1, 2, 3, and others. So that's the only difference as you are reading the different literature about a GP. That sometimes the moment they write 0, you start from N. The moment they write 1, you start from N minus 1. The powers of R. R is the common ratio, so you should be well conversant with it. And then another thing you should be knowing is that you are supposed to use the other formula of R. Remember? Now here, because we have already seen that this thing goes up to infinity, you remember we have sum to infinity of a GP, and we said this is the same as 1A over 1 minus R. This is the sum to infinity. And then proving them, you need to, this is the reading assignment. how to prove and reach there, it is the reading assignment. During your free time, you look for them, because last time we tried to prove. So let's try to see some examples, then we try to move on. Remember, what we are doing, it is to test for convergence of what? Of a GP, or of a geometric test. You can see examples there. Use the geometric test to check for the convergence. To check for the convergence of the following series. Of the following series. We have number 1. We can say summing up of 1 over 2 to the power n. This one here, we have generally used it, but it is okay to use it to see how it affects different terms. And we can have something still unique, which is 2 sum up. This is 3 over 4 to n. Sometimes we can add just number 3 sum up n is equal to 0 to infinity of 1 over 2 to the power n, because I want you to see something funny. Number 4 sum up, this is in, this is what? This is 3, 9, okay. 3 to n. Another one may be the one I may tell you to think about. You sum up n is equal to 2 to infinity 3 over 4 to n. So these are the questions we are going to try, and then we see what happens. Hope you have finished copying. So in this case, when you try to check properly, we can start with the number 1.
So I can't see the last number that side.
Hope you have seen it. This is the one, number 5. So let's go with the number 1. It is telling us that we are summing up of this is 1 over 2 to n power n. This is equivalent to what? Now the other way around, we can write this expression is to just write that this is the same as summing up. Then because a 1 will not be affected, it is to power n. And remember, this one, the moment they say that we are summing up, we are moving from n is equal to 1. Because we said if they keep quiet about this, then this n comes from n. And when you try to check properly, when we substitute, if you substitute in the first one, what will happen? We shall start with a half. Then we shall have this is a quarter. We shall have 1 over 8 plus other terms. This is when you try to check here, since r equals to a half, which is less than 1, then remember we have said, we have been specific. You pick, you get the formula, you confirm that it is a GP, you find that r is less than 1, then that is enough to confirm to you that it converges. And then converging to what? That is, you look for sum to infinity. That's the only thing we are supposed to do. Now, since r is less than 1, say r is equal to a half and less than 1, then this guy here, 1 over 2n, converges. So, using sum to infinity, we have this is the sum 1 over 2 to n equals to a over 1 minus r. Now we are finding it is converging to what? That's what we are finding now. And this guy here will be, our first term is a half, 1 minus our r is a half. Can you please try to see that this one here will be, this is a half, this is a half, this will be a 1. This one confirms back to us the other expression we got at first, where we used the infinite series. So it is the same thing we are getting now. And this is what we are doing. We are testing, when we have tested, is it convergent? We have seen it is convergent. Why? Because our r, this is the r we are talking about, is less than 1. Then it converges to what? You have to go ahead to use sum to infinity and find it. That is the expression we have got. So now when you check back from our questions, we have calculated this, which is okay. Now I want you to use I want us to go to number 3, which is now, this one starts from n is equal to 1, but this one starts from n is equal to 0. So we have to check. If you add just the terms, remember the other remark 4 from our work we looked at last time and the other lecture last week. We said that you dropping out some terms or adding some terms doesn't affect divergence or convergence of any series. So we want to confirm it here. And this is one of them. Let's try to see what happens. Now, for this is for number 3, which is summing up from n is equal to 0 up to this is infinity of 1 over this is 2 to n. This guy here, if you try to analyze properly, it will be of this nature. N is equal to 0. This is infinity. 1 over this is 2 to n. This is the same as writing summing up. N is equal to 0 to infinity of 1 over 2 to power n. Please look here. I want you to see this one clearly. Now, here, the moment you drop this n from n is equal to 1 up to infinity, it will not be this same question. When you drop these things and you just write like this one means that you are taking from n is equal to 1 up to infinity. This one here means from n is equal to 1 up to infinity. Not this one doesn't mean this or doesn't imply that. So you should be aware of that. Now, when you try to analyze properly, when you put a 0, we shall get a 1. The next one will be a half. The next one will be a quarter. The next one will be 1 over 8 and other terms. So when you try to substitute, let's try to see our r. R is the same as a half divided by 1, which is a half. Similarly, we can still test r equals to this is a quarter divided by a half, still to be a half. So since r is equal to a half and it is less than 1 still, then it converges. Then this guy from n is equal to 0 to infinity of this is 1 over 2n converges. And since we have seen that it converges, then we have to go further. Then we have to go further and look for it is converging to what? So summing up from n is equal to 0 up to infinity of 1 over 2n, this is the same as this is just a sum to infinity of a GP, A over 1 minus R. Our A is what? Our A is 1 now, not a half. This one here, you see, because we started here from 0, our first term is 1. Because the other time we started from n is equal to 1, our first term was a half. So that is the only difference now we are having when you try check from the previous work. I think yeah, it is here. You see, our first term here was a half. Now that is the only difference we are registering. This is a half, but this one here is 1. So this is 1 minus our R is a half. When you compute this to be a 2. Therefore, why that this one is a 2 but the other one was 1? I'm referring to this answer here. This one is 1, but this one here is 2. The reason behind it is one, that we have more terms here. Remember here, we dropped n is equal to 0, but here, sorry, here we dropped n is equal to 0, but here we have added it there. So that's the difference now. And this one must then be bigger than the other one, because here we have added more terms. These ones are less because we move from 1 to infinity. This one is moving from 0 to infinity. So we have more terms there than the previous. And if you try to see, we can now move on. That this one here converges, and it converges to that value, which is a 2. Now, let's try to see the next question, which is question what?
Excuse me.
Yes.
Then
Yes.
the other remark 4 doesn't apply there because it has affected the what? The convergence.
No, what they are saying to not to affect the convergence is that if it has been convergent, it will converge. If it has been divergent, it will diverge. But they are not saying that you remain with the same answer. That is what they are meaning. You get the answer which, if it has been convergent, if it has been divergent, it will remain divergent. But the answer, the numerical value you will get, it will be different.
Okay.
That's what they are meaning. Thank you. So let's go to number 2. Number 2 is this question here. This is the question for number 2. And we are having number 2 here. We have sum. This is 3 over 4 to n. And when you try to check properly, we know how to go about this. This is the same as
Good.
Yenze kunywa buji.
Yeah, Shava, the guy is recording.
Okay, for me, I actually thought I was the only one who wasn't seeing that guy.
Promoter kevuddemu bwe n'okabuuza oba okagyewa.
So, sorry, there is some disturbances, I think. Is it from the network? I don't know. A minute, because maybe my network is. Sorry, my network has been down. Maybe something is funny. So let's move on now. Sorry for that. So we have already shown that this thing here converges, and if it converges, we have to look for the value where it converges to. And when we do that, I think we shall have something fun as this, that we are going to sum. This is the 3/4 to n, and this one is equivalent to, this is 3/4 plus 9/16 plus 27/64 plus other terms. And this is the sum to infinity, which is a/1 minus r. And then when you try to do the simplification, you have this is the 3/4, then over what? 1 minus 3/4. So this is a quarter, this is a quarter. I think it will be 3. It will be 3. If it's not 3, you confirm that numerical value, please. The working is okay, and numerical. Sure. So let's try to move on now to the next phase, which is number 4. So number 4 is good. Number 4, it is this question here. This is the question we are talking about. This is the number 4. And then if we are to handle that, this is a 3, sum 3 to n, but now it is open. It is sum just. So this one here will equal to what? Sum 3 to n. This is the same way 3 to 1 plus 3 to 2 plus 3 to 3 plus other terms. And we know already this thing here. Now, you see this one here, what is our r? R equals to 3 squared over 3 to 1. This is the same way 3, and it is greater than or equal to 1. Since r is equal to 3 greater than or equal to 1, then it diverges. And diverges to what? So then sum 3 to power this is the same as, since we have said it diverges and we are lucky that we know the formula which is containing it, 3 squared, 3 to 4. This thing here will equal to what? This is n, because these are terms we know that this is the same as what? This is a over r minus 1, because we have this thing here. So you simplify, you'll get the answer, but it diverges. So what does it mean? That it keeps on changing, it keeps on changing, it keeps on increasing. Yes.
When you diverge, you change the formula to R minus 1. Why are you
Yes,
changing the formula?
but the
Minus
challenge
1?
is, okay, let's drop this. The thing is like this. When R is greater than 1 or equal to 1, we know that our sum of the first any term will be like this. It will not be the other way around. And therefore, here, the challenge here that when we take the limit, this guy here will not go to 0. And that is where the challenge is. And therefore, if R is greater than 3, we don't need to bother so much. That is the interpretation. Why? Because we expect this guy to continue. It will be like 3 to 1 plus this is 3 to 2 plus this is 3 to 3 plus and other terms. This is the same one, 3 plus 9 plus 27 plus 2, 4, 3. You see that, and the other terms, you see that the last terms are ever big, meaning that it must go up to infinity. It will keep increasing. When you put R is equal to 10, it will be bigger. So what we do? Okay, the best approach is to, if you find that your R is greater than 1, you conclude that it diverges, then you don't go to this formula here now because it's going to disturb your understanding. It's going to beat your understanding. What you do, you just come here and show the person that when you substitute, these terms are big and continuously increasing. And then you tell them that to diverge to infinity. So that is the thing. I'm not, let me withdraw the other statement of switching the formula. But it is true. It is true when you remember from a high school level. That is what you started with. But you were just using it, but not interpreting why. So, hope I've answered your question there. You look through question number 5, and then you do it during your free time. So I'm going to move to another type of test. So this is the P-series test. P-series test is on page. You go to bottom of page what? Page 42. Bottom of page 42, that's where we are going now. Bottom of page 42. Can you please go there and see what is there? Yes, bottom of page 42, I think, yes. You read through that statement, then I want you to understand it. I'm giving you 1 minute, please. So let's try to move on. Let's try to hope you have seen it and you have read it through. Now you see that expression there. They are telling you that when you are having a city, but now they are specifically on the type of a city, not every city, meaning that here this is a narrow thing. It is not so strong, but it is good. So when you try to check properly, they are saying, if you are having a city of this form, This is n to power negative p. Or this is just n to power negative p. And this one here can be written as you sum. But this one here will be 1 over n to power p. N to power p. The other side we use the k. And then, remember we are having two unknowns, so we can be specific and say, okay, our n now moves from 1 to infinity. N moves from 1 to infinity, meaning that I'm shifting n. And then when I try to see, this guy will be the same as, when I put n is equal to 1, it will be 1, because 1 to power p, it will remain, because remember, 1 to power any value, maybe to power 4, I'll get 1. 1 to power p, it will be 1. That's why I'm getting this 1 here. So don't get confused over that thing that you are substituting in. So plus, this is when it is 2, I'll get 1 over 2 to power p, because for it will not change. This is 1 over, this is when it is 3, it will be 3 to power p, and all other terms. And then, what are we saying? If p, you see where p is this value, and then I'm going to request you to go with this expression that more rather than this. When your p is greater than 1, meaning that if this thing here where it is greater than 1, then you just say it converges. But if p is now ranging from negative infinity less or equal to 1, meaning that when it is when p is less or equal to 1, then what do we know about this? That this one here will diverge. So if p is greater than 1, this cell here will converge. If p is less than 1, then this cell here, less than or equal to, I'm specific, it is less or equal to 1, then this one here will diverge. This one here diverge if p is less or equal to 1. This one converges if p is less than, if p is greater than 1. So you should be knowing what you are doing. You just need to see, only to see, and then you move on. Then we have specific or special terms which are already fixed, or answers which are already fixed. And then we are going to just take them because we are beginners. That if we are having
Excuse me.
Please.
Can you repeat for me how you see that p is less than or equal to 1?
Okay, let's do this. If I try to go back, we have said if you are having an expression of this nature, this is n to power negative p. This is the same as summing up n from 1 up to infinity. N is equal to 1 up to infinity. Of this is 1 over n to power p. Now, for example, if p is equal to 4, it is already greater than 1. Then what will happen? Our simple expression will be n is equal to 1 to this is infinity of 1 over n to power 4. So this one, because our n here is greater than 1, then this cell converges. But you have a situation where maybe p is equal to negative 3, and then the sum will be negative 1 to infinity of 1 over, this is 3, which is n to power negative 3. Or simply writing like this, n from 1 up to infinity of this is n. Now it will be positive 3. Then this one here will diverge. I think I'm not deviating so much from this. You see here we prove that it diverges. And here, if you pick randomly your P, it diverges. So that's what I'm telling you. That if this guy here, if this P, you pick P and it is positive or greater than 1, it will be, it is specified it must be greater than 1, then it will converge. So I was still telling you that we are having some special tension here, or special formula here, or special values. That when we are dealing with even values, like 2, we have a 4, a 6, like that. Those are even values. Already some formulas are fixed. So we have to just pick them and get used to them. That if you are summing up from maybe n is equal to 1 to infinity, of this is 1 over n squared. This answer ever will be the same as pi squared over 6. Those are the remarks. When you check remarks at the end of page 42, these are the remarks. They are the formulas they are giving. You will see that they are continuously using the powers of even numbers. The next one here will be 4. Then when it is a 4, they are giving you pi to 4 over, this is the 90. That is what they are giving you. So meaning that this is equivalent to sum 1 over this is n to 4, n is equal to 1 to infinity. So that the answer ever will be like that. And then when you check, all the numbers are not catered for in this case because little is known. We know little about them in this case here. Their answers are not yet what? At the track. So you should be aware of that. So the reciprocals are not so much known here. Not because they are not existing, not because of what, but little. We cannot just fix them now. So we can see, or let's try to see some examples here, and then we move on. Again, we can try to test using P series for the convergence of the following series. Test using P series for the convergence of the following series. We can have sum 1 over 2 or n to what? N to 4. That is 1, 2, sum, and have n to 3 or to negative 3. 3, we can have sum n to can we take to negative 4 or to 4? Yeah, let's move on with that. There are few because it is a simple thing. It is just a pinching or method. It just tells you this one here, you move with it. So let's try to see the solution here. Number 1 is okay thing. Number 1, we have this is 1 over n to 4. This one is written as this is sum n is equal to 1 to infinity of 1 over n to 4. Since we can have sum from 1 up to infinity of 1 over n to 4 in the form of sum n is equal to 1 up to infinity of 1 over n to power p. P equals to 4 and it is greater than 1. Then sum 1 over n to 4 is convergent. So this is the thing that you see that the expression here we have, you look here, you see the expression we have got, this is the thing. This is the one here, that it is the same as this. This one is the same as this and the same as this. So I've said if we can write this expression in form of the other. Arinda, yes?
No, I'm not saying anything. I'm sorry.
I'm not getting what you are saying.
I'm not saying anything. I'm sorry.
So, and this one here, it is written in form of the other expression you have just seen. So we can, meaning that when you just pick, by comparison, this and this, our P is 4, and then it is greater than 1. We conclude that it converges. And then, if since it is uneven power, therefore, we conclude that our sum, 1 over n to 4, we have already seen, this is the same as pi squared over 90. So this is the thing. And let me have finished with that. So you try these two.
It's powerful.
Yes.
Despite powerful.
Yeah, you are right. Thank you. Now, this one here will converge. This one here will diverge. Please try to, this one here will diverge, this one here will converge. Please try to calculate the thing and you see where they're coming from. Now, sometimes they may confuse you with some few things here and there. Like if I have something like this, if I have a special question where they say n is equal to 1 up to infinity, or maybe 1 over 2, then maybe k or n power 4. So you see this one here, that we are having this guy, if you are to solve this, then you'll say, okay, this guy, n is equal to 1 up to infinity of 1 over this is 2n to 4. Remember, 2 is independent of n. So this one here will be summing up, or a half outside, n is equal to 1 up to infinity, 1 over n to 4. And then this one here, p is equal to 4. Then you make a conclusions. So sometimes they will give you something funny, and they can try to them together, 2 to power n to 4, then they put a bracket there. For you, you should remain on your way. You should remain on your way that me, I need something of this nature, 1 over p to power something. So this one here, you just need to take this is 1 over 2 to power 4, then times n to power 4. And then you factorize out this guy because now it will be independent of n. So that's the only thing I want you to know. And then you continue with other things here. So it should be that method should be at fingertips. Sometimes they will ask you why. Why are you saying? Sometimes we are like the way we're going to see. Why are you saying that maybe 1 over n is equal to 1 up to infinity of 1 over 2 squared n of power 2? They may be asking you, why are you saying that this one here is convergent? You tell them by P-series test, it converges because this is in form of 1 over, summing up of 1 over 2, sorry, of 1 over n to power p, p is equal to 2, which is greater than 1. So this is, you should have an argument, but don't just say it convergent, divergent. So much we are going to cover much on this method as we are moving on with other methods or other tests. So the next test we are going to look at, it is the compulsion test, which is on top of page 43. Compulsion test. You go to top of page 43. On the top there, it will be there. So don't worry, you will see it. I'm just giving you half a minute to read it through. You read through that work, then we try to move on. On top of page 43. So let's try to move on and see what happens there, and then we move on to other things for better. So what are we saying? That pick, if you're having a city, which is maybe AK, I think when I say AK, you know what I'm meaning that K is varying. K from 1 up to infinity of this is AK, that is the meaning of that city. Then we should know this cell here should be, this sequence here should be above 0 or equal to 0. Sometimes we can allow that. K comes from N, meaning that we don't want negative this, negative this, negative this. No, we don't want those things. Then we may pick a convergent cell BK. We pick it or we get it, but on condition that this thing is satisfied. 0 is less or equal to AK is less or equal to BK. What are we meaning? That the one we pick or the one we get should be bigger than the one given to us. Hope I'm clear about it. You pick this guy, which is already bigger than the one given to you. If this one converges using all the previous methods you have seen, then you conclude that also this one converges. If this one here diverges, also you conclude that this guy here diverges. That is the arrangement, or that is the relationship. So, and in this case, it is a simple thing. We are just going to apply a little bit of analysis, then we try to move on. Now, for example, if I have number 1 there, and this is example what? Example 3.56, because they are not calculated, I'm going to calculate them with you. So I have 1 over, sorry, this is funny, sum 1 over n plus 1, this is squared. We want to prove that it converges. We want to prove that it converges. So when you try to solve this guy, we are having this is now remember from here, when you try to see from here, look here please. This is a cell when you try to look at it, but when you are analyzing it, you pick a sequence. So you pick a sequence from the cell, then you analyze it. If this guy here converges, also you say that also that thing converges. So that is what we are supposed to. You pick a cell. After picking that cell, you confirm that indeed you pick a sequence from the cell. So this is the thing. You pick a sequence from this cell. After you also pick this guy here, which is also a cell. Then you convert this guy to a cell. After taking this guy to a cell, you test if it converges or diverges. If it converges, then what does it mean? That now you go and compare with the cell you started with, and also say that it converges. And this is the thing. Now, this is from here, from summing up 1 over n plus 1, this is squared. You are free to take k or n. So I'm picking now my cell from here. Sorry, I'm picking my sequence from here, and I'm going to have 1 over n plus 1. This is squared. Now, this one here is a sequence from this cell. This guy will be less or equal to, you remember the other format of just reducing on a number of n's you are having or number of unknowns you are having. It is the same thing we are doing now. This guy here will be less or equal to 1 over, because I'm reducing on the denominator, it will be less or equal to n squared. I'm dropping out a 1. And if this is true, then sum of 1 over n squared. We are testing now if, then we test, or we can say then we test for convergence of the cell. Now we are converting this guy from being a sequence to a cell. The cell 1 over n squared. So this is what we are testing. You are free to test using any method you want. By P series test, comma, this guy here 1 over n squared converges. Because of what? Because P is equal to 2 and it is greater than 1. So you see that this one, P series can help us so fast to know. So if we call this one equation 1, so from 1, we conclude that also the other sequence the other cell we started with converges. So this is the thing. You start with a question, you pick up that question, which is a cell. From the cell, you pick up a sequence. You try to analyze and see that that sequence can be expressed in something which can be tested first. This one here can be tested first compared to this. And after testing this, you obtain the cell of this sequence here. And after obtaining it, I've seen that with the P series test, I can see clearly that this thing here converges. And since I can write these sequences in this form, which is 0 less or equal to maybe 1 over 0 less or equal to 1 over n plus 1 squared less or equal to 1 over n squared, which is what we wanted. Then, since this one here by cell over this one, it converges, also this one here, it must converge. So that is what we are testing. I'm going to go to number 3 before I go to number 2. I'm going to go to number 3 before I go to number 2. And I have what? From we are given a cell which is root to k, 1 minus k squared plus 2. So we can say from this is the root of k minus 1 over this is k squared plus 2. You see this guy here, I've just picked a sequence from this cell. Now I can drop some few things, but you take care on what you are dropping. You take out of care on what you are dropping. So if I'm dropping this negative 1 here, because it is contributing on reducing this guy, meaning that this answer will remain, because I'm removing a 1 which would have reduced it. So it will remain this. This is k over this is k squared plus 2. Then when I try to see if I can drop a 2, when I drop a 2, because it is contributing on making the denominator big, then it will be less. This is k over this is k squared. So root of k over k squared, this one here can be found as 1 over, this is k to power half over k to power 2, which is the same as 1 over, this is k to power 2 minus a half. And here we get 1 over k to power 3 over 2. Therefore, we have, I'm going to pick up this expression but dropping the inner part. We have root of k minus 1 over k squared plus 2 is less or equal to 1 over k 3 over 2. And when you try to check properly this thing here, I'm going to pick now a set of this. So, summing up, this is the 1 over k to power 3 over 2, k from 1 to this is infinity, it will equal to what? It converges. It converges by, P series test with the P equals to 3 over 2, which is greater than 1. So, it implies that by compulsion test, this guy here, root of k minus 1, sum over this is k squared plus 2, converges. So that is how you do the thing, and it is easy. That's why I was forced to rearrange these things, these tests, because of one thing. I realized that some tests should come earlier than the other. So like this one, it is easy. It is a matter of just analyzing, but you should take out of care when you are dropping these values here. When you are maintaining less or equal sign, sometimes when you drop it becomes greater, so you protect that less of that greater thing not to come. So you should be aware of what you are doing. And I want now to go back to number 2. Then we think we remain with one more test, which is going to take us maximum of 30 or 25 minutes, then we leave. So, number 2, we have sum -1 to this is the n plus 3, n over this is the 2n to 3 plus 5. So, I'm picking up now. I'm picking up a sequence. I have -1, n plus 3 of n over this is 2n cube plus 5. So you see this guy here is less or equal to, when I drop this 5, it implies that I'm making this one bigger, -1 n plus 3 of n over this is 2n cubed. Now, this 2, I mind less about it, but I'm more interested in this. Or else it can be less or equal to -1 to n plus 3 over, I've dropped a 2 and I've crossed this guy. It will remain n to power 2. So now if I pick up this, which is -1 to this is n plus 3 over this is n squared, this guy will be less or equal to, because this one is having positive, look here please look here, When I put n is equal to 1 here, it will be positive 1. When I put n is equal to 2, it will be negative 1. What I'm meaning is this, something funny, like this. I have negative 1 to the power n plus 3. So this thing here will be, when I put the first n, it will be 1. The next one will be negative 1. The next one will be 1. The next one will be negative 1. When you try to check these things. Now, I want only to go with positive z. I want to pick up only the positive z to drop the negatives. What will happen? That I'm going to make this guy even. That whenever I have n, it is even. And therefore, I'm free to take a 2n. When I take a 2n, it implies that everything I'm going to substitute to be even. And therefore, this is less than negative 1 to power this is 2n over this is n squared. And probably this is less or equal to, because I've made this one even, then it is positive every time. So it will be 1 over n squared. So I'm picking up now, I have something funny. I have negative 1 plus this. N over this is 2n cubed plus 5 less or equal to 1 over n squared. Because I've picked only this, the last one I want. So now I'm taking now the series of that, and we are going to say, so by P series test, please, even if you use the GP, geometric test, even if you use infinite series test, it will give you the same thing. Sum 1 over n squared is convergent. Convergent because P is equal to 2 greater than 1. So it implies that by comparison test, also this guy here will converge. By comparison test, also sum negative 1 to n plus 3. N over this is n squared of 2. This is the cubed plus 5 converges. So that is the thing there. That is the thing there. I think let me give you one more example here, because I know this thing is not so easy for everyone. So let's have one more example. Can I do 2 or 1? I think I can do 2. Test convergence of the following using P series test. Using comparison test. Using comparison test. We test the convergence of the following using the test comparison test. So we have the first one, sum n2 to infinity, n to 3, n to 4 minus 1. No, let me take a 1 here. Let me take a 1. Let me take a 1 because I don't want to bring in many new things now. Number 2, 1 over, this is the sum, 1 over 3 to n plus n to 2. So number 1,
Excuse me, sir.
we have
Is the second number, is it 1 out of 3 to power n? The whole power is n plus n squared.
yeah.
The second number, the power on the 3, is it n plus n squared or it's just n?
It is the 1 over 3 power n plus n squared.
Thank you.
Thank you. So let's move on with the number 1, sum n to 3, n to 4 minus 1. We have this is the take. When we pick the sequence, we have n to 3, n to 4 minus 1. This guy can be less or equal to, is it less or greater? This thing here will be greater than n is cubed over n power 4. When I drop this, it will not be less. And this guy here will equal to 1 over 4. So the 1 over n. So what we have seen is that we are having n to 3. We have space. When we are having n to 3 over n to 4 minus 1 is greater than 1 over n. So, but by comparison, by P series test, sum 1 over n diverges because P equals to 1. Now you see here, this one we proved already that this thing here diverges where we had a half plus a half plus a half, then we said it goes to infinity. Now by comparison, but P test, P series test, you will see that this is the same as writing 1 over n to power 1. But we said whenever n is a 1 or less, we say that it diverges. Because this is already 1. Also, n over 3, 4, n to 4 minus 1 diverges. Another thing, this is a contradiction still. Because we have said for you use less. So, if you fail to get less, it is an indication that it diverges. Actually, if you are so keen, we would have concluded from here, because we cannot get something less to enable us handle this situation. So that one is also another remark, that if you cannot get something less, then it is enough to tell you that this thing is going to converge to diverge, because that is an indication of the failure of the question. And therefore, that is still enough to show that it will diverge if you cannot have a less. But in this case, since this is a 1 it diverges automatically. Maybe if we sometimes they can give you like this 1 over n squared n to 5 over maybe n to 6 plus 4. If we try to duplicate question 1, you will see that you have to just take this is to 5, this is to 6 plus 4 less or equal to n to 5, n to 6. This is 1 over 6, 1 over n. And then you automatically, this one here, n is equal to 1 to this, 1 over n. This one diverge with the all means by any test you want. By any test you want, so you conclude that also this one here diverges. This is when you try to duplicate question 1. You will see that you have to repeat this same thing here. Then you get 1 over n. This one diverges. 1 over n diverges by a set. Then that is enough to.
That's it. Isn't that greater than also?
No. Because the reason why I've put here greater, the reason why I use the greater here is 1. This one I'm dropping this guy, but what is the role of this guy? It was reducing, meaning that if you were dividing, then this guy was giving me bigger answer compared to this, because here it is big compared to this. But now this one here, because this one its role is to add on n. You see, it's like when I have maybe 10 divided by 20 plus 2. And another one is having 10 divided by 20 minus 2. You will see that this one here, the moment you drop this to the answer we get here will be big, it will be bigger. But the moment you add here to this answer will be smaller. That is the thing. So here when it is addition and you are dropping, it will be less. When it is subtraction and it is dropping, it will be greater. We analyze these things in that way. I know you can manage to maneuver. Let's look at number 2, then I try to see the last test, then we move on. We are having number 2, which is the testing 1 over this is 3 to n plus this is n squared. And in this case, what we are doing, it is we pick a sequence which is 1 over 3n plus n squared. If I do that, what will happen to me? I may decide to leave out our n because actually here I may decide to do 2 things. You drop this guy, it will be less or equal to 1 over 3 to n. And here, I want you to continue with this. Here, you are going to pick up a cell here. Then you see this guy here. You see this guy here. You don't say by p-test because this is not a 2. So it will not work for you. Meaning that here you must check using a GP. You will check this sequence here. You check that this guy here converges using a GP. It will come and it converges. Or else, if you have started from here, you can also say 1 over 3 square n square. This is less or equal to 1 over n square. And when you try to check here, by p-series test, you can see that 1 over n squared converges. You see here you have 2 sides you can drop. You can either drop this n squared here, or you can drop 3 square, 3 to power n. So you choose between the two, but still the answer will be the same. That's what I wanted to show you in this example here. And that is the beauty with it. You are free to drop either this guy or this guy, and then the answer will come. So I want you to use the knowledge of the knowledge you have covered so far to show that indeed this one here converges. If it converges, the answer is convergent.
Excuse me, sir.
Someone is asking?
Yes, when you consider the first one, 1 over 3 power n, and you use a geometric test, and you use a geometric test, it will diverge.
Yes?
Since the common ratio will be greater than 1.
The common ratio cannot be 1 because
it
try to see this guy here is 3 to n equals to 1 over 3. The next one will be 1 over 9. The next one will be 1 over 27 and others. I think our error here will be what? Is it a third? You check. You check. But that is how we do it. Then you say 1 over 9 divided by 1 over 3. So you get 1 over 9, 1 over 3 as your error. Yeah, it will be this, it will be that, it will be that. Then you continue, you know the ratio tests. So let's go to limit compulsion test. You check on top of page 44. Then I think today we shall stop on this one. Limit compulsion test, top of page 44. Top of page 44. It will be top of page 44. Can you please go there and try to see what is happening there? So, limit compulsion test. This is the one we are having. So here you are supposed to pick series AK and also BK. Both of these ones, they have positive terms. All positive terms. So if they have positive terms, everything should have positive. This is what the question will be. Then this is what we are going to pick up. This is what we are going to pick, and it should converge in most cases. If you want divergence, then you should pick the one which diverges. But now the most common problem here is, if you are lucky, you can get it. If you are not sober, you may fail. But with all the tests you have covered, you can easily get it. Now, what is important now here, you get the sequences. You don't get the series, but you pick the sequences. You pick them. This is AK given. This is BK picked. This thing here, if it goes to L as K goes to positive infinity, then we say that. But now, this L here should not be 0. We say that if BK is convergent, then we conclude that also AK converges. But if BK diverges, then we conclude that also AK diverges. Please look here. I want you to pick up this concept well. this is what has been given. This is what you pick, or they may pick for you. You know how to pick a sequence from the cell. This is a cell, but you pick this sequence. Also, you pick this sequence. After picking that sequence, you divide that two. Then you take a limit. After taking a limit, if you get an answer which is not 0, then you make your own conclusion is that if you have seen that this lower part, which has been given, or which is given to you, or which you have picked, is convergent, then you also determine that also the other one convergent. That is the only whatever we need to know. One, pick a sequence from the given series, divide the two sequences, take the limit. After taking the limit, check if there is any answer which is not 0. After getting the answer which is not 0, go and check now. If the BK, that is this is now you test from the sequence, sorry, the series. If the cell BK converges, then you also just know the cell AK also converge. That is the thing. That is the thing. But I want you to know one trick here. I want you to know one trick here. You target to have the same powers, the same highest power of the numerator and the denominator, of the numerator and the denominator, as you are picking BK, as you are picking the sequence, sorry, the cell BK. That is the target you look at. What does it mean? If the highest power, if I have a cell AK equals maybe n square plus blah 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 there, over this is maybe n to 4, blah 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 there. What will be my BK? I will pick BK such that when I divide these two, it takes me to power 4, meaning that I will pick BK, the highest power will be to 2. So that when I multiply these two, as in the process of dividing, it will be n to 4 over n to 4. So that I can be able to divide using the L'Hopital's rule in case I have reached there. That is the trick I want you to know, that you target the similar powers of the highest values in the two, the denominator and the numerator. And that is what we are going to target today. Let's see it, then we move on. With an example probably, then we give an exercise, then I think we chat properly. This is the thing. I have n square plus 1. Please, we are doing that example. This is example what? Example 3.57 in the handout. N to 5 plus n plus 7. So what we are going to do now, it is to have, let our cell AK equals to n square, equals to sum n square plus 1 over n to 5 plus n plus 7. This is what we have. And BK be the same as 1 over n to 3. Now you look here. Look here, please. Look here, please. You see, when I take the reciprocal of this guy, ever take the reciprocal, because the problem is going to be up, not down. When you take the reciprocal of this guy, this is the sum. Look here. When you take the reciprocal of this guy, it will directly affect up. And then if it is the lower part, if the lower part is the problem, don't take the reciprocal. What I'm saying is this. If this thing was like this, n to 5 plus n plus 7 over this is n square plus 1. Then if this is my AK, then I would have picked some BK as n squared. So n cubed, because it will be affecting up, down now. So that is the thing you should be keeping in your head. Because we are interested in convergence or divergence, one of the two. So now this is, from here we have said you pick AK, these are sequences now, not serial. And also we have to pick BK. Where are we picking them from? We are picking them from the series, but we are getting now what? Sequences. So remember we said immediately after picking that, you divide AK divided by BK. This thing here, it may be given to you. Please look here. BK, this sum BK may be given to you, or it is you to pick it. What is the question? The question will be AK. Sum AK, that is the question. BK, it is you to either to get it, or they will give it to you, depending on what they have done. Now, when you try to see in this example you're doing, it was not given. It was not given, but you have to use it. The reason why they are calling it limit comparison test is that in the due course of this comparison test, there is a limit you take. But the other one is called direct or comparison test. By the way, I forgot to tell you that. The other first one is called either direct comparison test, or comparison test. The other one is called direct comparison test or just comparison test. This one here is called the limit comparison test because you must take a limit at a certain point. So here we are having n squared plus 1 over n power 5 plus n plus 7 divided by 1 over n to 3. This is equal to n squared plus 1 over n5 plus n plus 7 times n3 over 1. So now this one here is going to affect up. So this one here will come to this point, which is n to 5 now plus n to 3 over n to 5 plus 7, plus n plus 7. Now, from that point there, we are supposed now to continue. This is the AK over BK. Now, what is next? It is to take the limit. Taking limits, we have, I think you know that taking limits, when you are having the same powers, you go to L'Hopital's. So you know those things, L'Hopital's rule. And if you go to L'Hopital's rule, we are going to have this is the limit. As this is n goes to infinity of AK over BK, we are going to have what? We are dividing through with the highest power. We are getting 1 plus this is 1 over n to power 2 over, this is 1 plus 1 over n to power 4 plus 7 over n to power 5. This is the limit as n goes to infinity. Then you know everything down we're going to turn to 0, and then we are getting a 1. Since limit AK over BK as n goes to infinity, goes to 1, not equal to 0, because we said it should not be 0, then with the sum 1 over n cubed, or sum of bk, equals to, this is the sum 1 over n cubed, convergent by P series test, since P is equal to 3 greater than 1. Then also sum AK equals, this is the sum n squared plus 1 over n5 plus n plus 7 converges. So that is the thing. That's how it comes. That is how it comes. That's how it comes. We shall pick up from ratio test. Shall pick up from ratio test next time. And the exercise is the exercise for today's work is 3.58. Please don't forget to read through the reading assignments. I think next time when we meet, we shall complete our course. So you should be able to read it through and interpret what you have done. But now the problem is one here. The problem is one. Some people don't submit their work at any time.